Welcome to homework.
For this problem, there are several different things that we need to do. The first thing is we need to name the two copper and oxygen compounds. So the first one is named copper 1, Roman numeral 1, oxide, because the charge on the copper is 1. And the second one is called copper 2 oxide, because the charge on this copper is 2. And then this copper right here is just plain old solid copper. Okay, the next thing we need to do is calculate or predict over what temperature range this reaction is spontaneous. Okay, and we were given this data. We were not given the info for the entropy for the copper, but I found that from a table, standard entropies. So in order to find the enthalpy of the reaction, the delta H of the reaction, we need to find the sum of, that's this weird thing right here, the sum of the products minus the sum of the reactants. So our products are the copper oxide, copper 2 oxide, and the copper. So it's negative 156.1 plus 0 minus negative 170.7. So then if you do that, you get negative 156.1 minus a negative is the same as plus 170.7, and that gives you a value of 14.6, and that's kilojoules per mole. For the delta S, this is in joules per mole Kelvin. So for our products, it is 42.6 plus 33.2 minus 92.4. So 42.6 plus 33.2 minus 92.4 is negative 16.6 joules per mole Kelvin. Now, we need these to be both joules or both kilojoules. So I'm going to change this to kilojoules. So I'm going to divide it by 1,000. So it's negative 0.0166 kilojoules per mole Kelvin. So to find out where this will be spontaneous, that would mean that delta G would be negative. So we're going to set this equal to 0. And then any temperature that would make this negative, any temperature that's greater than that would make it negative, perhaps. So delta H is 14.6 minus T, which is what we're trying to find. And the delta S, the delta S is negative 0.0166. So I'm going to make this negative 14.6 equals positive 0.0166 T, and then T would equal 0.0166 divided by negative 14.6, which can't be. So 879.5 Kelvin. So this would be at any temperature then, not equal to this, but that is greater than. So the temperature would be greater than this 879.5 Kelvin, and that would give you the temperature where this would become spontaneous. The last question is, why is the entropy, the molar entropy, this delta S right here, why is it bigger for the copper 1 oxide versus the copper 2 oxide? So entropy is chaos or disorder. And so that disorder is much greater in the copper 1 oxide because there are 3 atoms that make that up, versus in the copper 2 oxide where there are just 2 atoms, 1 copper, 1 oxygen.